Hello everyone, this side is Sujit, your big data Hadoop trainer. So let's just have a little bit of audio check. Can you hear me all? Just type Y in your chat box. Yep, just type a Y in your chat box so that it is available to me. Yep, Pankan, I can see. Thanks, yes, Vinu, I can see. Okay. This is just to check there are no audio issues. Waiting for responses and okay, I believe there's no audio lag or anything. Great. Okay, so let's begin. Let's begin this interesting world of get into the interesting world of big data. All right. So coming to big data, let me first introduce myself. Okay. So my name is Biswajit. This is my profile. You can see I have around 9 years of IT experience on big data development. There's a few certifications I have. I have done my MSc and BTech too. And I have around 10 to 12 projects I've done in this big data environment. I've mainly used Java, Python, and Scala. That will be mainly helpful for you to learn these big data technologies. May I have, can you please type in the chat box if anyone has any sort of programming language background? Waiting for responses, please. If anyone has any programming language background like Java, Python, anything, you can type in the chat box. We'll just take a 1 minute feedback just to know that how much you're into the big data or into this programming side. Yes, thank you. Cool. I know it's very good you have into in Java and Swift. It will be very helpful for you. May I know if you have done in core Java or like only Java part? Okay. And others, I believe, right? They're into basic learning things. Can everyone please type their graduation backgrounds, if any, like, so that it will be more helpful for me to understand the background of yours so that we can begin instantly. Okay, with that being said, let's begin the interesting world of big data. All right. Okay, so like, what is big data? How are we being going to be benefited from big data? So is the question. And how do we actually use big data? And what are the advantages of using big data? Those are the things we'll be looking forward. Okay, and we'll be taking care in the upcoming slides. Okay. Yep. So like, what is big data actually? So as you might see that it is a very generic term these days in the IT industry, that there is a thing called big data and everyone is talking about big data. There's a hype about big data, many things going on with big data. So let's have a look into it. Mainly they are talking about terabytes and petabytes of data. We are talking about terabytes and petabytes. So just to give a glimpse on how terabytes and petabytes and how this is being generated, let's have a look. So all know that 1 MB consists of 1024 KBs, and let's go 1025 MB is 1 GB that we normally are locally used to in our computers, right? And then when we have our hard disk size mapped, we actually call it in 1 TBs or something. But the big data thing starts from here. Once we multiply in TBs, we get 1 petabyte. That's 1024 TBs. Right? And when that is again multiplied 1024 times, we get something called 1 exabytes. So mainly we are dealing in big data. Whenever it is being dealt, it's always mainly dealt in terabytes, petabytes, and exabytes. All right. Any questions up till now? Good. Thank you. You can type all your questions anytime just by raising hand symbol or giving it. Yeah. Okay. So it's big data is all about analyzing this extremely large data sets. All right. Large data sets that can be of any big company. It can be of any mode, be it online data, offline data, right? So it can reveal you patterns, it can reveal you trends, it can give you many interesting things that you can get out of the data. So basically, the challenges that we have with the data of the size that you just saw, there has to be captured. That you have to capture the data, you have to curate the data, you have to store the data. You can do search, you can do sharing, we can transfer, we can analyze the data and visualize the data. So as of today, as per the documentation, when this documentation that was composed, we have 295 exabytes of data. You can believe that how much data we have. All right. So I believe all good. Any questions up till now? You can just type in your chat box. Yep. Okay, we'll take it to the next slide. So this is actually, you can say, image view of big data. So like we have to, starting from the left, we can actually see that there are some tools that we need to know. There will be some statistics that we have to follow. There will be a cloud computing thing. There will be a big storage. There has to be database support and related terms. You can just have a look at it. There will be terabytes of data to be processed. There will be also mobile data that we can also process. There will be something called NoSQL. We'll learn about this later. And there will be something called compression. All this summarized to big data. All right. Coming up to the next slide. So with that being said, we'll come to a very important slide called the types or the properties of real data. Please ask your question. Feel free to ask your questions in the type in the chat box. Okay. So first is the volume of data. So let's begin like this. We all use Facebook, Twitter, online shopping portals, and any websites, important website that we use. For the information, everything is being stored. If you ever have a click, even if I am drawing this thing, okay, this online thing is storing the information somewhere. Okay, so this is the thing that the data is ever growing. Whenever you log into retail e-commerce giant, they'll store your data. They'll store what the products you've seen. Whenever you call from any operator, they will store your data. Whenever you go to a retail market, online shopping store, like online shopping store you go, they will store your data. Offline shopping store, they will always store your data. So one property of data is that there is a big volume, a chunk of data that we have to do. All good? Okay. So with that being said, we'll come to an interesting topic. Interesting thing is called the veracity of data. So we'll come to a thing. Anyone can suggest that what can be a veracity of data? Just for interaction, anyone can say that what is veracity of data? Please type in your answers. Yeah. Okay. So veracity of data actually means the quality of the data that you have. Let's take an example. Suppose Maruti Suzuki, a big company, has suppose say 10 years of data. All right. So before big data, they were actually collecting data for they actually stored all their data of their customers, 5 to 6, and they stored it. Okay. And they didn't know what to do with or what they were doing unless and until you analyze the data, you can't actually make meaningful data out of it. So they had all the things like customer name, the customer ID, the customer's car number, everything they had. But when they applied big data to it, they actually could get meaningful data out of it. Like suppose they churned the data, they manipulated the data to find out that who are the customers that were having, like say, having a car for the last 10 years. Mhm. So having a car for the last 10 years, Maruti Suzuki could actually go on and give them a good replacement policy. So coming to the veracity point, the data that was lying there for like 5 to 6 years, once you make meaningful data out of that, it becomes the veracity of the data, the quality of the data, and the accuracy of the data. On other terms, we can also expect that some of the data coming from online are e-portals. All right. Some of the fields, some of the columns, some of the contents of the data might not be also useful. Like say log servers, we have log servers for Google and Yahoo, all big companies. Some of them might not be useful, but that also shows us the quality of the data. All right, everyone with me? Good. Just feel free to ask all your questions. With that being said, we can now come to a very important topic called the variety of data. So let's talk about a bit of the variety of data. We have two types of data, structured and unstructured. Okay, so like what's structured and unstructured? Like structured, we can think as whenever there was no big data, we can think as a little timetable on the first page of a school diary. You can say you can see the days on the left and the periods on the right. You can actually find out that on what time is what period or what class you attend. That was a structured data where you could actually find out the meaningful information in the least amount of time. All right. That being said, that means sorry. So that means it had columns and rows. Just keep in mind whenever we're talking about structured data, we are always talking about data which is having rows and columns, where the data can be given a table format, and I believe that's the best format the human being has invented to represent that kind of data, just for as of now. And another thing is unstructured data, like say text files, a big text file or a ebook, okay, a video and audio and log files or documents. It is important to note that whatever can't be represented through a table has to be called unstructured data. All good? Please ask your questions if you have any. Okay, good. With that being said, like there's another thing will be coming across later, that is called semi-structured data. We'll come across that. So that will have some sort of, you can say that might be a structure or might not be a structure. We'll come across those things later when we go more and more into this course, so that to understand why semi-structured data is also important. All right. Okay. So next we come to another important thing, that's called the value of the data. Important. It is not to be confused with the veracity and the value of the data. So the economic value of a data means how much information you can take it out of the data. Let's take an example. Suppose e-commerce giant in today's market, you can say eBay or Amazon. They have around 1 year of, suppose say they have begun their big data platform and they're storing 1 year of data. You are the loyal customer for the 1 year. So when they have 1 year data of you, they can actually see patterns, that what is the time that you are logging in from your mobile device. What are the things that you're interested in buying from them? What are the important sub things? You can say you have bought a product and you have brought another product too with that. So 1 year of data they have of your like your customer data. They have 1 year of data, right? So on 1 year of data they can do some predictions. I mean to say that seeing that for 1 year, suppose you have bought two mobiles, so it is quite high likely that you will buy a mobile, might be the next year or from for your friend or someone. So that is called prediction. The more they have the data, suppose say you are again a customer for that for them for the next year, so they will get revealing patterns out of the data. Everyone good? Yep. Please ask, feel free to ask any of the questions. So that is actually meant by the value of the data. How much you can make meaningful things out of a data to get extract more and more and more revenue. All good? Yep, thanks you. And the last thing, the properties of data, is the velocity of the data. We'll take a use case of like Facebook. Suppose on two mobiles, suppose you have posted a picture on Facebook, you have posted a nice selfie of yours in your Facebook, and your friend is going through his wall when he sees a picture. All right. So your friend actually puts a like on your picture. So it takes a fraction of a second for the like to transfer from your friend to the Facebook service and come to you. So this is actually attributed, this is actually called the velocity of data. The speed of the data being generated, like a click or a comment or a like or whatever it is, and flowing it into the enterprise, like the Twitter, Facebook. You give a tweet, it can be seen by everyone. For Facebook, the way I explained, the for logs, like server logs will have this kind of data. Some telecoms, yeah, customer directories will have this kind of data, where you call like 2,000 customers are calling for one operator, and they have to store every kind of data for that. All right, so this is actually attributed to the velocity of the data. All right, so with that being said, any questions on this slide? You may please ask me. Okay, all good. I think everything is clear up till now. We'll proceed to the next slide. So now that were the properties of data, this is actually, those are actually main questions when actually in the interviews, that please tell me the related properties of data. They can ask you that. With that being said, sorry, with that being said, who are using big data? Or like, whom shall we provide our service to? Is an important thing to be understood in this business. So the main customers are these verticals. A vertical is something where it is a line of business, you can say. So web, any company that is running a website, a big website, they will have data, and the best possible way in today's world is to process data is big data. The e-commerce websites we have discussed, like Flipkart, Amazon, eBay, whatever it is, they will have to use Hadoop. They will have to use big data to churn the data, to make the data proper. Once we get into the functioning of these things, it will be more clear to you. Mhm. So then we'll have to come to the telecommunications. All telecommunications, they have to store the data by default as per government rules, and also they can also store their data, make meaningful data out of it. All right, so that to bring out with more better offers than others in the telecommunication market, where there's a huge competition going on. The more they analyze the data, the more they will be able to come with better offers, and the more customers they're likely to get. All right. Yep. Thank you. The third sector is like government sectors. The government sector spans to many number of verticals. They have, suppose, the sea monitoring system. They have their nuclear power stations. They have innumerable hospitals and everything. They have to take care of everything. So to store this amount of data, the best option for available for them is big data. Okay. Well, when we get to the use cases, it will be quite good to see that how they are being used in this verticals. Next thing is healthcare and life sciences, a very important vertical using big data. I'll give you a use case. Like suppose a customer has gone to a healthcare on some disease, all right, and the healthcare has a case history of the disease, which suppose say 15 customers. They can say what are the recommendations of medicines that has been given, what are the use case that has been done. So seeing those things, they can actually give recommendations to that uh, I mean to say to that patient, that how they can actually proceed with that. Sounds good? Good. The next the next thing that we can discuss are banks and financial services. The best thing happening, they are getting the most leverage out of big data. Credit cards, debit cards, customer information, everything that you may say, banks and financial services are using the best of it. All right, they can churn their big data to give more offers to the customers on credit cards, better credit card offers. They can actually have a look at the credit history of the customer to store the data. They can store the credit history of the customer. They can see that how the customer is using and can promote better offers for some or not better offers for some for those who are defaulting on the loans or something like that. All right. That being said, the last big data customers, big thing happening for them is the retail industry. Like you can say Walmart, they're using big data now to bring out more better offers, more better more better products for the customers to see that how what are the things that they need to do to bring better products in the market. All right. Any questions up till now? Yep. Just type in your questions if you have any. Yep, thank you. I believe there are no more questions in this slide. With that being said, let's proceed to the next slide. So, what is Hadoop? How we can use Hadoop? Let's see something. We can see a funny living thing called, this is an elephant actually. Can anyone tell me, can anyone type just that? How can an elephant be related to Hadoop? Just can anyone type? We'll just give 20 seconds to it. Okay, cool. I'll give you this synonym. Why actually Hadoop is related to this level. This is actually a funny interview question. Sometimes you might get that why this is being used. Friends, I'd like to tell you that please keep a notebook and a pen ready. There'll be some questions or some things that I will be telling as interview questions. You can just have a note down to see that, to have just a backup of things. Okay. So this funny thing is called Hadoop actually. What happened? The person who designed Hadoop, his name is Dougherty. So when he was designing this thing, so what happened is he was not finding a name that what can I name this technology? What can I name this technology? So his son was playing with a baby toy elephant, and he asked his son that what is the name of the toy elephant? So he told Papa, this is Hadoop, or Dad, this is Hadoop. So that is why the name is Hadoop. Sounds funny, right? Yeah, that's how we got our name Hadoop. Okay, but coming on the technical part, let's look into it, that how and what is Hadoop. So what is Hadoop? The standard definition would say that Apache Hadoop is a framework that allows for distributed processing of large data sets across clusters of commodity computers using a simple programming model. I believe that we couldn't make out much meaning of that, right? Just to see that what actually is happening out here. We couldn't make it out, right? So let's try to make it much more simple. Let's take one use case. Okay. So we have a thing called mainframe servers. Mainframe server is a device. You might say mainframe server is a technology which is used to store data. Okay, these are the big corporations which actually make the servers. Okay, they store the data. Big companies like whatever verticals we saw in the previous slide. These companies will store data in the mainframe servers. These servers are designed that they are a bit fault tolerant. The data is not lost. You can read much data in a high rate. In this use case, suppose say we have to read 1 terabyte of data. We all know, right, what 1 terabyte of data is. We have gone through that. So suppose this is one machine and it's having 5 input-output channels. So what is that input-output channels? Input-output channels are the ways how you can interact with the data. It's like having a tank and you have 5 pipes connected to it for data inflow, for water inflow and water outflow. All right. So computer is something which is having input output channels. So you have input output channels. We can actually divide that only, and we can say that we have 200 megabytes of. We can share 200 megabytes per second. With that, we have 40. We will require 40 minutes to either read 1 TB of data or give information to that to write 1 terabyte of data. All right. Now let's come to our Hadoop design. All right. Okay. So this is a typical, you can say, Hadoop setup. You have 4 computers, or in the image it looks something like a CPU. Okay. So something you can actually, for as of now, think that these are things which can store data, like our mainframe server. So we have 4 machines. We have 5 input-output channels for each of them, you can say. Okay. And we have the each channel 200 megabytes of second. So you have so you can actually go up to 1000 nodes. Nodes means these machines. We can go up to 1000 nodes, but in mainframe servers we can't actually go up 1000 nodes. We'll see in a moment why. So when these are all connected parallelly, it is called a distributed cluster. We'll come across the word distributed frequent times and we'll discuss it later. Let's to see why it is called distributed. Okay. So suppose this 1 terabyte data was stored in these 4 machines, okay, and it is distributed equally, or it is distributed. Suppose in this one, suppose say you have 300 MB of data and related wise data. It is there in these machines. So it takes only 10 minutes. It takes only 10 minutes just to read or write the data from this system. Okay. So now we come across an important question. Suppose if anyone is developing a company, he has a mainframe server. He can provide his customers with insights that okay, I have this thing. I can store the data in the server. Why should I go for Hadoop? What is the big thing? Okay, chalo, theek hai. It's everything okay that to have a distributed cluster and everything better, right? But why should I go for it? See, friends, a mainframe server, just to buy the mainframe server, a company has to invest on $75,000 just to store the data. It comes with some limitations, some advantage. But when you look into Hadoop, when you look into the distributed cluster, it has only $2,000 per year. So that gives you better maintenance. All right, we can see the picture, right? That how actually this thing is very beneficial. Friends, we are discussing these topics because these are this. With that being said, it gives us a good foundation and understanding that why we need to understand big data. What's the big thing in big data? These are all the big things in big data. You can see the cost reduction and how much a company can reduce its cost and get parallel processing. One advantage you get that there is a huge margin of cost difference. Okay, and the next thing, you're always saving time. The more faster you can give the results, the more better you are in the IT industry, right? Any questions in this slide? Okay, I'll take that as a no and proceed accordingly. So we'll have a basic introduction of Hadoop. So actually Hadoop, when Google published some white papers is something, friends, which we have when we release something new product. We try to talk about a new product, we have to write that in a white paper. So back in 2004, Google published one white paper, okay, and they there mentioned the thing called Google white papers, okay, and they mentioned the thing as Hadoop. Okay. So in Hadoop, we have two components. All right. One is HDFS. HDFS is a short form of Hadoop Distributed File System. Just think of it like this. It is as simple as your local hard disk. Your local hard disk is NTFS, Network File System. It can also store data. So like that, for Hadoop ecosystem, we have something called Hadoop Distributed File System. It is derived from Google File System. Okay, primarily it was called Google File System because actually Google developed it on a large scale. All right. So for the time being, we'll note that this storing mechanism in Hadoop is called HDFS, Hadoop Distributed File System. We'll go into it that why did we require a different file system? We had NTFS, we had other file systems. Why did we require Hadoop distributed file systems? Basically, friends, these are the use cases where the interview questions will come up. That why do you require HDFS? Why do not other networking file systems? Why our network file systems won't be handy in using Hadoop? So we'll see to that. These questions will be clear in those slides. Next thing is called Apache MapReduce, or you can say MapReduce. It is also derived from Google MapReduce. Okay, we'll see into it what is MapReduce. You can think MapReduce as a technique to leverage the power of HDFS, or a technique to use Hadoop, the technology of Hadoop. To give an example, similar example is like, suppose you have Adobe Photoshop. Okay, to store the data, to store the photos of Adobe Photoshop, you need a local hard disk, right? And Adobe Photoshop is an application or a mechanism a way where you can manipulate the photos that you have stored or shot or whatever you can do with the photos in a meaningful way. In a similar way, MapReduce is an application or a technique which uses programming language to churn the data, to manipulate the data. All right. So I believe your understanding on the basics components of MapReduce is clear. If you have any questions, please feel free to ask me on Apache, HDFS, and MapReduce. Okay, cool. With that being said, we can proceed to the next slide. Okay. So friends, in this thing, we'll be requiring your interaction, but please type into the box whenever it is required. I have developed this technique to explain MapReduce. I've been doing this for like 3 years from now, explaining. I have named this thing called VBox theory. It's going to be quite interesting. Friends, we just understood that what is the thing called MapReduce? It's an application or a terminology used to access HDFS or to make Hadoop more useful. I can assure you, everyone knows MapReduce. how a MapReduce thing works. Okay, we'll see how. Friends, we have a problem in our hand. Suppose we have a box, okay, and you have different colors balls. So friends, I would like to ask you that, is it possible to count from these boxes? I believe yes. So a normal technique would be that if you give any one of this, what you would like to do. So like suppose say we can see that we have different four color types of balls. We can actually have something called collection boxes. All right, we can have collection boxes for this thing, and we can actually take the red balls, okay, drop it into this. We can have a yellow balls, we can drop it into this, and the same for the subsequent number of things, right? And just for the thing, then we can have a count. Okay, red balls, how many we have? We have 14 of them. We have 5 for the yellow balls. We have green, we have 3 for them, and the purple ones we have like 4 for them. We can easily count that, right? So this is actually basically MapReduce. But friends, whenever we are going for big data Hadoop, it will be always confined to something much more in a high large scale. It will always be. Let's see how this works. Even the thing, we'll have a very big box kind of a thing. Let's suppose say we had a small box, we could count it easily. But if we had a very big box, is this number of balls? I believe this is not feasible for it is not feasible for us to count this number of balls, especially when we have computers. We have computers with us to make our life easy. All right. So how do you do this thing then? How do you actually plan to use these things? How do you manipulate big data in using this big box kind of thing to count this number of variables? That is the ultimate goal. We have a very big box, lot of number of balls in it, different colors. How to do this? With the previous slide to be mentioned, suppose say we have something of split boxes. Split the data into some boxes. We can divide it uniformly or ununiformly. All right. So once the data is divided, it is very easy for us to count them. We can have four persons for us. Okay, we have 4 persons. Okay, we can now have individual count of them, or someone can easily do it. All right. To make it much more simple, let's do like this. Let's from each of the box, let's give it a count. So we can see that for first box we have 14 number of balls and subsequent numbers, and we can have a data populated for each number of boxes. If you give it a count, friends, for each of the boxes, you will find that each of the balls has 14 and 4 and 3 and 5 number of red, purple, green, and yellow. All right, we can see that. So what is now left actually to get the result? We can then have a box to collect all the red balls, right? That seems to be a viable option for us to give it a more meaningful structure. And we can have subsequent boxes for them. Okay, we can have a box for the green, we can have a box for the blue, we can have a box for the yellow as well. Sounds good. So friends, what can be done next? We can have one box just to give it a count, and the other boxes just to give it the counts of the individual items. Okay, and we can sum it up, having a big box having the individual counts. Sorry for this number, actually 14, it will be has to be 56 actually. All right. So friends, I can tell you that this is actually the technique which big data uses, or which Hadoop uses for all its kind of manipulations. Okay, but there's a specific technique how to use it. There's a specific mechanism on how it uses it. So friends, I'd like to ask any questions up till now on this slide, that how these balls are being given the count, how these balls are being counted in a structured way so that no error is there. I'm waiting for your questions. If you have, please type it in the box. I will have a 10-second hold. Okay, cool. I believe everything is clear till now. Okay, let's see something more interesting. Okay, so let's try to name the steps. Let's try to name the steps. These steps has an individual name. Let's try to name the steps what we are doing. So we can see that this might be considered the input to the computer, or you can say the input kind of a thing, where the data is or where the object is, what we have to do. All right. So from this thing, for the next step, we actually split the thing. We actually divided the thing. So basically, what Hadoop developers named is, okay, we have to split the thing. Just name it as splitting. All right, that's the naming convention for it. We'll see later that why this naming convention is, why this naming had to be done for this. Third thing, which we can see, is called mapping. The third step is called mapping. Why it is called mapping, my friends, I will tell you. From each of these boxes, we had to map the thing. We had to give it an identity. The red ball had to be given identity of 14 number of things. The purple ball had to be given 4 number of identity values, and so on and so on, just to make our work much more easier. Everyone with me? Yep. And then the next process is called shuffling. Why it is called shuffling, I'll tell you. See friends, from the first box, we had to give the information to this. From the second box, we also have to transfer information like this. For the third thing, we also have to transfer information, and the fourth box also we have to transfer information. So actually, when this is happening in a computer or in the hard disks of the computer. For our naming convention, friends, we'll always call disk as a storage where the data is stored, okay, and the RAM as memory. All right, we'll always consider the disk where the data is stored as disk, or the storage part is called disk, and the memory part or the RAM will be called as memory. Throughout this course, this is really the naming convention. All right. So with that being said, these 4 boxes will be stored in different locations. It might be stored in different, you can say, different folders, or it can be seen that it can be stored in different parts of a computer or in different storage locations. We'll see into it why it will store in different locations. All right. So what happens is this thing will be transferred across the network or across the storage, okay, to get the data into one place. So this is actually called shuffling. Yes, friends, it's called shuffling. So that data is shuffled across to one of the particular boxes of the particular required storage. You can say storage type or storage output, whatever it is. And the next step is called reduce. Why it is called reduce? You can actually infer it easily that whatever the data we have, we're summing it up and giving it a much lesser value. So it is being reduced to some values. And the last part, we can say it is called the result or the output. We can say that. So with that being said, friends, I would like to say that do you have any more questions in this slide? Any topic you didn't understand? Any? Please think of interesting questions. We'll have a 1 minute break to see that if we have any more questions. So friends, do you have any questions? Try to think of any out of the box questions. You can type it in your chat box. Anything out of the box, that why this is happening, when this is happening, anything you can think of, please let me know so that I can also develop a better answer for you to give you more insight. Anything you might have to see problematic in this, you can actually see this as a use case. Suppose in your school you had your teacher actually brought for the sports some kind of a thing, a very big box with all the balls clubbed in, and you had to divide the balls into 4 different boxes to be used by different teams, you can say. So this can be a real use case, that how did you manipulate the data in that time. Right? So yeah, Vainu, you have a very good question. How many nodes? The nodes are like this. In this use case, nodes is not you can tell a significant, or you can say important thing to be discussing on this, because nodes is always decided on the configuration. Nodes something means a computer. Nodes means a memory. You can do this on a 1 node or a 10 node thing. You actually have to think that how many nodes will I require for this thing. Nodes are actually decided on how much data. I'll give you an example, Vanu. I'm thankful to you that you brought up this question. Suppose you have a computer having 1 GB of disk, right? And you are trying to like manipulate the data, or suppose you have 10 GB of data to analyze. So how many nodes would we require? At minimum 10 of them, right? So that is how a node is decided, that how many nodes do we need. In this thing, we can have this on 1 node. Node basically means a computer. Node basically means a system which has disk and which has memory to it. Am I clear, Vainu? Just type yes if you have understood, or I will explain it to you once more. Yep, I think Vainu, you have understood the thing. Just to recap it once more, node is something which we use to decide that how many like how much data we have. We decide on that. We'll come into nodes on later basis that to see how things are working. Just to quickly sum it up, the Hadoop code structure that is a mail to you. We have a basic thing of Hadoop on this. Okay, these are the code structure we have. Just go through it. We will go through this each of these in very much details. Okay, and we'll go to Scoop. We'll go to Spark, and we'll go to Spark SQL. Okay, just to go into it, we'll look into Hive. What is Hive? How it is will be used. We'll sing Spook, Spark, Spark SQL, Spark streaming, machine learning, and graphics. Don't worry, we'll go on to a detailed understanding. All right. And for the first demo session, this is the slide. Okay. So with that being said, friends, I think we'll come to end of the first demo session. I believe it was very interesting for you. Please leave a feedback on the mentioned ID if you have any sort of feedback. Okay. Yep. Thank you everyone for participating. My name is Biswajit, your Big Data Hadoop trainer. Please feel free to leave a message once again if you have any sort of